I'm going to work on some pathways right now so you can see the type of question that you're going to get on the test. You will get 4 of these on the test. You have to complete 3 of them.
So you get to choose.
Yep. So for the first one, I'm going to do 1 propanal to 2 propanamine. You need to have your look-fors. If you see a C double bonded O, you've got to get rid of it. And the only way to get rid of a C double bonded O is to reduce it. When you reduce it, you'll get an alcohol. Here's another look-for. When you go from here to here, you'll notice the functional group has changed positions. Anytime you change positions, you need an elimination. When you have a double bond in the carbon chain, the only thing you can do is an addition. After a while, this becomes very repetitive, and it's the same thing over and over and over again. Folks, I'm going to be moving quickly here, so I'm going to get rid of this. You must be able to draw the molecules in order to do this. Propanone, 1,2-dichloropropane. So the first thing I do is I look at both molecules and try and figure out what I have to do. So you can either work backwards or you can work forwards. Once I see C double bonded O, I go to a reduction right away. Get an alcohol in there. Now I notice I've got a functional group over here on the first carbon, but not here. That means I have to do an elimination. To get a functional group where there wasn't one before, you need a double bond. Now I'm going to add Cl2. I'm going to go to propanal to 2-propanone. I'm noticing that I've got to move it. I'm also noticing that I've got a C double bonded O. The only thing you can do here is reduce. Now I'm moving functional groups, which means I need an elimination. To get this molecule, the only way I can get it is to add an alcohol in and then oxidize. The only way you can make a C double bonded O is to oxidize an alcohol. Question?
So the reason why we couldn't substitute it is because it's not a single functional
yes.
group?
Yeah.
Okay.
It's got to be single bonded. So somebody asked the question why we couldn't just do a substitution. You can't substitute double bonded functional groups. The only way to make them is to oxidize. Hi, Lucas.
When we added the alcohol, we have just written add OH, or do you want to add HOH?
Either one's fine. Okay, I want to do one more from this category, and then I will do 2 esters. So I'm going to do one that some people may not have seen yet. Propyne, this is a tough one, to 2-chloro, 1-bromo propane. The only way to get rid of multiple bonds is to do additions. So what we're gonna do here, and some people in this class won't have seen this before, is we're gonna add, and what that's gonna do is break one of the bonds. So I'm gonna put BR there, then I'm gonna add to break the second one. So I'm gonna add on the CL. So I'd add HBr, and I'd add HCl. We are gonna do 2 ester problems. Hi, Katie.
When you're adding, you get rid of the double bond.
You go from triple to double to single.
Okay, I'm just talking about a different one when you got rid of the O double bonded to the C, and then you eliminated, and then it's this one.
Yes, when you add, you always get rid of a double bond.
Okay.
Okay, here we go. We are going to go propopropanoate. First part of review. Anytime you see the C double bonded O, that's the propanoate. The tail is the ill part, so the propyl. Okay? Now, anytime you see an ester, you have to hydrolyze it. So you have to cut it in half. Anytime you cut an ester in half, you'll end up with an acid and an alcohol. Every single time. Now, it's saying what we want to make is 1 propanol and 1 chloropropane. So we already have a propanol, so we've got to turn this into 1 chloropropane. Anytime you see a C double bonded to O, you got to reduce it and get rid of it. You've got to reduce this twice. Carboxylic acid, aldehyde, alcohol. Hi, Katie.
Did you say it gets like cut in half to make a acid and an alcohol?
Yes,
Okay.
every single time. So now all we have to do is substitute to get our 1 chloropropane. Hi, Manahil.
Wait, why did we?
Anytime you have a carboxylic acid, if you reduce it once it becomes an aldehyde, you reduce it the second time to make the alcohol. We have to get back to a single bonded functional group because we can't work with double bonded functional groups. So if you go back and look at our oxidation and reductions, one of the ones you have to memorize is carboxylic acid to aldehyde to alcohol. That's a double reduction. The first reduction is going to the aldehyde, the second reduction is going to the alcohol. I'll come over and show you that a little later.
On the test, do we write reduction times here, or do you want to calculate?
Yeah. Okay, if you ever start with 2 molecules and they tell you to make it into they'll want you to make it into an ester. What do we need to make an ester? We need 2 things. We've got an alcohol, we've already got that, but we need a carboxylic acid. So I would have to do a substitution to get an alcohol. I would have to oxidize that to get an aldehyde, and I would have to oxidize it again to get a carboxylic acid. I know that looks like I just did a lot there, but I've said over and over and over, you've got to memorize this one. You have to memorize it. Alcohol to aldehyde to carboxylic acid, or oxidize times 2. Now, we'll bring down that alcohol, and we'll do a dehydration synthesis. What does dehydration mean? To get rid of water. What does synthesis mean? To bring it all together. I want to keep emphasizing a point. It looks like a lot, but this is all there is. Okay? It's not like there's an infinite number of roads to go down. Hi, Nandani.
Do you want us to circle it on the test too, or does that not matter?
No, if you said dehydration synthesis, I'd know what's going on. Or DS if you like.
Don't erase
Mr.
it
President,
yet.
can I take a picture?
To make an ester, you need an alcohol and you need a carboxylic acid. Okay, we are done. We're done part 1.
There's a second for it.